In this video, we will move on to step 2 of our binomial real options pricing model. We'll construct the data section of the model. We need to build an entire binomial tree. We'll break that into 3 sections, the first of which is the data section. We won't be able to fully complete the data section because some of the values are calculated in the other 2 sections, but we can get started. If you haven't completed the discounted cash flow section, section 1, you need to pause the video and go back and complete that section. Let's enter the values that we were provided. In the problem, we were provided with an annual cost of the discovery phase. We'll enter that as a positive value, where this is the cost section of the data section. $2,000 for the clinical phase and $15,000 per year in the marketing phase. Then we have an income section. Only one of the phases has income. That's the marketing phase, and that is $20,000 per year. We were provided with a growth rate, and the average growth rate was given at 10%. And it had a standard deviation according to the problem of 100%. Here we can calculate the up state and the down state. We see the formulas for these here, the up state and the down state. We're going to use the EXP function in Excel. There are 2 ways to do it. So far, you are familiar with using EXP to find the value of E, which is in this equation. So we can do it the way we have been doing it. EXP 1, that gives us E, and then we could raise that to the mu plus the standard deviation, and that will give us probability of the up state. It's 300.4 something percent, but we'll just round it up to 300% for the purposes here. Of course, Excel will use the full value in all of its calculations. It just shows the value without decimals in this cell. Now, another way to do this would be to recognize the way the EXP function works. E is calculated EXP to the first because E is assumed in the EXP function. So another way to write this would be to say equals EXP, then whatever E is raised to, that can be in the parentheses. So we're raising it to the mu plus standard deviation power, and you can see we get the same result. So either way you want to do it, doesn't matter to me. I'm going to go ahead now and enter the downstate formula, and that is E raised to the mu minus the standard deviation. And we get 41%. We're provided with R. R was 0.06. We can calculate the probability of state down. However, we will not get probability of state up until we complete the entire worksheet, so we'll have to wait for that. Let's go ahead and calculate the probability of state down. We have that formula right here. Let's enter it. Equals. I'll go ahead and do my fraction first. So I want to get the whole fraction. I have a numerator over, and I'll get the denominator here. 1 plus, I'll go and get R right there. I'll close off my fraction. Then I will subtract that from the Q up state. So for right now, I'm going to get an answer that is not the final answer. It's an interim answer. I'm not going to know the answer to this model until I complete the entire model and then run solver to solve for these values that I need. The final value that we can enter to complete the data section is the value that we calculated in the previous video, the NPV using the discounted cash flow method. So I'll just equals and point to that and press enter and get that minus $268. Now the binomial and the other values will have to wait until I complete the rest of the model. This concludes the data section portion, video 2. To complete the model, move on to step 3 or video 3 to complete the net cash flows section of the model.